Very welcome to the afternoon session on the first day of the Atal FTP. So we have an eminent academician par excellence, Professor Dr. K.V. Gangadharan, Professor, Department of Mechanical Engineering, Center for System Design, NITK Surathkal. And the topic which he is going to present today is AR/VR, the way forward to provide experiential learning. Now I request Dr. Manoj Babu, Deputy HOD, Mechanical Department, to formally introduce the resource person of the day. Dr. Manoj Babu, sir.
Good afternoon, sir. Good afternoon to one and all those who present here. It's my pleasure to introduce today's our speaker, Dr. K.V. Gangadharan. Basically, Dr. K.V. Gangadharan is professor in mechanical engineering and head of the Center for System Design, National Institute of Technology, Karnataka, Surathkal. He has earned his PhD from IIT Madras in the year 2001 in the area of railroad vehicle dynamics, ME from NIT Trichy in the year of 1992, BTech in Mechanical Engineering from Calicut University in the year 1989. His area of research are system design, vibration and its control, smart material and its applications, structural health monitoring, and product design. He is also actively engaged in creating learning materials for experiential learning of basic concepts in engineering. He has teaching and research experience of 28 years and industrial experience of 1 year. He is actively engaged in industrial consultancy and sponsored research project and has more than 120 research publications to his credit. He has filed several patents, 7 patents, 4 in the area of medical devices and 3 in smart material application. And also he is the in charge of amateur radio facility at the NITK Surathkal. Thank you so much, sir. We are very happy to welcome you for our 5D FDP, sir, Faculty Development Program, sir. Thank you, and thank you, one and all.
I can go ahead, no?
Yes, sir. You can proceed, sir.
Okay. So very pleasant good afternoon. I know you have we had 2 sessions back to back, and had a quick lunch and sitting. I don't know whether all of you are sitting in separate places or you are in the campus. Anyway, it's the norms. It's the norm now to make people to attend programs continuously, even if you are online. So let us see whether we can make sense out of what we are looking at today. And I'm just trying to make sure that the afternoon session is not going quite dry. So we'll have something to do with what we have actually done rather than talking about the theoretical things. So I will be looking at AR and VR. How are we going to look at it from the education perspective? I'm here to slightly introduce to get the continuity. I am sure that both the speakers earlier might have introduced, but allow me to do put my screen up so that I can start with my presentation. Hope you are able to see my screen. Okay. Now, welcome on behalf of National Institute of Technology, Karnataka, Surathkal. We look at the growth in terms of NIRF ranking. So 21 to 29, 13, then to 10 is the present position. We are also sensitive to the nature. So we are trying to make NITK a campus with carbon neutrality. Hope one day we will be able to do that. Today, you have actually started a very important topic on augmented and virtual reality. I'm sure that next 5 days you will have exciting journey on how to make use of AR and VR for both for education as well as for if you are interested in entrepreneurship and setting up something, how do we do that? I'm sure the items lined up will have sufficient content to make everything together in such a way that you realize how the potential of both AR and VR and also its pitfalls. Okay, today I'm trying to focus on AR, VR, the way forward to provide experiential learning. So I'm sure that you remember before Christ and AD, the year, the way in which we have been talking about the years. Now, I'm sure you remember this, and the way in which we now look at number of years is presently this way. It is BC and AC and the small period called DC, which happened to be the during COVID. And we have been doing our best possible to make things happen online. God forbidden if no more lockdowns. But if there is, or can we make learning experiential? Even our students have been doing great job. Whatever restrictions they had, they have been doing their work online. And both the students and teachers together have been really pushing forward to make sure that things are happening. Now let us come to AR and VR and assume that your management asks you to market your institute. Quite often we may have to do that. So how to attract new students to your campus during this pandemic? How to provide a realistic view of your campus and facilities? How to provide an immersion of the viewer to your campus facility, and how to introduce lab and experiments. So I'll take you to what we tried out few years back. This was 2010, much before we put all our solar panels, etc. And that time we were trying out whether we can give much more immersive activity of equipments. So in that process, we have joined 6 cameras, GoPros then, in such a way that we are able to get 360 views. And this is not taken from the presently available single camera, which takes 360 views. So now, if I can just go to a little planet and give you the view, you can really get into, I hope you are able to see my screen. You can really get in like a little planet or as an eagle to NITK. Now, I'm sure that all of you have been using this kind of virtual tools quite often, but look at it from the academic perspective. So rather than a toy or a game apparatus, let us look at it from educational perspective. Now, instead of getting into this, if you are able to get into a turbine, or if you are able to turn around a turbine and see what is happening, or even if it is in operation, turbine is in operation, if you're able to get in and see that, those things are the opportunities for VR, which provides much more experiential approach towards every learning module. Now, in 2010, we tried out few things like this. We wanted to create how our classroom looked like, and probably we also tried how our laboratory looked like or our facilities look like. Obviously, there was not much of a demand that time for this because everybody used to come to the class, come to the location and see it. We wanted to see how each lab can be at least demonstrated. You can just get in and see, turn around, find out what is happening. All that is possible. And we also tried giving full information about the institute. Because demand was not there, we did not update it, because each of this facility can be updated, and you can give once in 3 months updation, etc. So this is about providing a view of your institute from the branding perspective. Okay, from there, let me just go to one of the lab. If I'm able to get into a laboratory, wherein, say, I'm taking you to the strength of materials lab, and I'll just get in. There's a classroom in the lab itself, because your instructions you need to give. And if you're on a mobile, you can even turn around and see how each of these things are. I'll just take you to one experimental setup. Now, here we have done little more than what normally done on an virtual reality kit. So here I can go near the equipment I can also look around, find out what is happening, what is there, etc. And if you want to see much more closer view, we have provided a picture. You can get the views. Then we also started giving you simulation, Lekhupada, and then video tutorial. So I can just go and click on this. It will open the video tutorial. I'm not extending that. You can just see that when later, because we'll try to cover more material rather than demonstrating it. You can go to Lekhupada. If you click on this, you can get into Lekhupada and the simulation. So all this put together, we are trying to enrich the learner's experience of getting into a lab. This is much before he or she comes to the lab, remember. So in advance, if I'm able to give them a view of what is happening in the lab, that can really make them do experiment much quicker. Remember, this experiment in a civil engineering and mechanical engineering department obviously take more than 45 minutes to explain, tell them what knobs to be turned and what precaution to be done before doing the experiment. The same thing can be done like this, and student can come prepare. Probably on an online activity, you can give a 10 questions and conduct a quiz, find out who are all able to get above say 6 or 7, then allow them to do the experiment. Now that 45 minutes you have already saved, because virtually you have done the experiment, demonstrated to them. They are now coming ready with questions. Why is it happening like this? They are much more inquisitive. What will happen if something changes? All that. So this is one approach. Now let me go back to my presentation. So we just saw how do we look at AR, VR for marketing your own institute. From there, let us see the changes which has happened both in terms of institute as well as the way in which we train people have really changed. So you can argue whether you are going from the Facebook to the ape or ape to Facebook. I am leaving it to you to decide what way we are moving. And world with engineer and without engineers, we have changed a lot. And we have been literally middling with the world, with the earth as such. And who are the people who are really middling with it? The engineers. So we have the responsibility to make sure that we are putting our effort to make sure they understand, the engineering graduates understand what they are really supposed to do. So how do we get the help from the advanced technologies is what we are looking at. Here there could be some amount of repetition because in the previous class also I'm sure that they might have mentioned few things, but for the completion let me just mention it. So look at virtual reality and augmented reality. Virtual, you're entirely on a virtual domain, nothing is physical there, whereas in augmented reality you're imposing things on, augmenting things on an actual workspace. So your camera is on, and on the what the camera see, on that you are going to put things. So virtual reality you can very well recognize by having a headset on the head, and you have a complete immersive activity. Obviously you feel that you are in that environment, you are taking an object and putting it together, you can do assembly, etc. And it's extremely good, and hopefully tomorrow you will have a demonstration on such things. We have a team whom we are working with. We have requested them to be there available with you. I hope that they might have got a slot if all the slots are not engaged. Now look at the way in which we are looking at that VR application. Suppose if you have a patient, the 3 students are looking at a patient. It's not a real patient, it's a holographic patient. It's only a created image. So each one of them are seeing the person in their headset, and as and when he touches the chest, headset gives them, yes, he has a chest pain, he has this, that. So they are able to get the feel. If they just see the normal patient, obviously this input is not going to come. And this gives them an immersive activity for learning. And it can be extended to technology. And you can also put items together, you can do assembly, things of that kind. And going beyond virtual to augmented and further, we have mixed reality. Before that, some of the technical application of an AR. So assume that in a new environment, you wanted few connections to be made, and the person who have been employed for that is not available or he has got transferred. You have been asked to take over, and there is no time for you to be trained on everything. Assume that you have an augmented reality toolkit already made ready for the plant. You take the tab, go and focus on the item. It will tell you what all connections you need to do. Each connection is meant for what, and it can also tell you if something has gone wrong or if it has not been connected properly, etc. Or if you are in a new location, obviously, when you take the camera out and show, it can even identify which is the building. As you move, you can even give the items, how you need to move to that location, etc. And then from VR to AR to mixed reality, wherein think about a piping condition wherein I have one wall to be replaced with another wall. Unfortunately, the new wall which I have, the dimensions of the connectors are same, but the height is slightly different. That means before I buy that item, I wanted to see whether this wall can really fit in my piping. So actual material, that is actual world, then an augmented reality, plus you are also trying to get a physical object from elsewhere and try to fit in. That's how the mixed reality will work. This is on to augmented reality. Kindly see the difference between virtual, augmented, and mixed reality. I'll show you some applications later. Did we have a technology shift? I'm sure you are able to recognize how the audience have changed. From an opera or some theater like this, it has gone to 3D. From 3D, think about people all are blind like this. It is people sitting with head-mounted devices, HMDs. Now, assume that you have, it is a video from YouTube. You can just, I'm just playing it. There could be an advertisement first. I hope it is not there.
This demo presents an AR-powered virtual manual that identifies physical objects, such as electronic devices, inspects their elements, and provides required details on their functionality. In our case, it's a coffee machine. And you know what? Even on a simple coffee machine, buttons don't always explain everything, or they may be indicated in a different language. After the application recognizes the machine, it shows all the buttons, including different kinds of coffee, hot water, automatic cleaning, and standby. Upon the tap of a button, corresponding information is displayed.
Here, it is not necessary that you should be just getting the information just like this. It can be a language barrier which we are overcoming, or the symbols which is used, because
the value
all
of
that
such
can
a manual
change.
becomes much more evident when you deal with a more complex device, such as a car dashboard or machinery. Now let's see how it works. Our core augmented reality development platform for Android identifies an object by recognizing its image using machine vision. When the image is recognized, our core provides the object ID and its position, which allows to augment the front panel of the coffee machine with a virtual manual. Such manuals can be created for virtually any type of device, including any consumer electronics, such as washing machines, air conditioners, remote controls, and kitchen appliances, cars and other vehicles, where coverage may vary from dashboards to electronics under the hood, various types of industrial and medical equipment. Please feel free to contact us.
So now you look at this application extending to a laboratory. Now, assume that each one of them now presently come with a mobile phone, obviously, and you don't need to spend too much time there. You can just ask them to view it through a manual or a procedure of an experiment, an IC engine, or if you're just trying to explain an oscilloscope for an electrical or electronic students, or if you are trying to assemble some things put together to give you a new device, all that can be done with these kind of approaches, wherein obviously you need to make it in advance, keep it ready so that you can use it for educating or training people. So I also wanted you to just get a feel of some of the devices. Just have a look at the device. You can also look at the price. Of course, it is, I might have taken it at least 1 week before, so there could be some changes. The costliest one, HTC Vivo Pro Focus Plus with 6 degrees of freedom VR set, costing you 1.25 lakh. And it is also available at a cheaper rate of 50 plus items are also available. But we could not do that kind of an approach when we wanted to do it for our activity when lockdown happened. We used Google Cardboard. Obviously, it is available now in the open as an open source. You can ask students to cut this and make these kind of things. We also used our laser machine to cut it and give items for the students. You can just send it across to your students and they can use their mobile in that and still have an VR headset available. So there is always a way to overcome the constraints. And it can have a way in which it is tracking your eye. So there are headsets which will track your eye and tell you, you can even instruct, you can blink once, blink twice, all that kind of an instruction can be given in order to activate. And if you want to get a much more immersive feel, you can be inside a cave. It is called cave automatic virtual environment. So you will be literally getting into a cave, and that will be a virtual environment that can give you much more deeper immersion in the domain. Look at this example. So whatever virtual or real, you can see the person who is lifting the headset and seeing what is really happening. So now I'm sure within the next 5 days, you will be getting across many of this software and things of that kind. We use Unity and Unreal quite often. And there are also other software development kits which is used for VR and other AR software which are Euphoria, Wikitude, ARKit, and ARCore. ARCore is from Google. ARKit is from iPhone, and many such toolkits are available. So you will be getting exposed. I'm sure that you will be getting exposed to all this in the course. We'll take one example and see whether we are able to appreciate the application of AR so that we feel motivated to work on it. So AR applications could be on automobile or indoor navigation, manufacturing, design and prototyping, inventory management, construction industry, and education. But of course, I'm trying to focus on education. I'll spend few minutes on other domains. Assume that I want my car to give me input, what kind of assistance it can provide by looking around. So I want an AR device that is head-up display, and on my the screen itself, not on the hood screen, it's on the windshield itself. I want the information to come. So earlier it used to just say how much distance you have from the next vehicle. But now it can also tell you what you need to do and what is ahead of you. And now the future AR hood will give you driver assistance. You are already this much close, and you can, the speed at which it is going is less than what you can do. You can cross, you can take, and there is nothing coming from the back. All this input can be given by an AR assisted driver assistance as such. So driver assistance system can provide this. This is one application of an augmented reality. Remember, the real picture on which your augmentation happens. And depends upon what is the field of view. So earlier it was lesser, hence we had difficulty, but now the field of view is slightly bigger, so you will be able to do things much easily. So now you look at this picture, it gives you are already using a map and you have a navigation which is happening. So it says what you need to do, and it also says, okay, this is a speed, this is a distance between the vehicle, you are free to take a turn, because it is also looking at the back and saying that, okay, nothing is coming. hence you can take a turn. And the display is coming onto the front screen itself. Just show you another video. When you want to do modifications, how do we get the design done correctly?
My name's Blaine. I write for Gizmag's emerging technology website. We're here at the Ford Immersive Vehicle Environments, which has been certainly the highlight of the tour for me today, because it's a virtual environment in which you can fully explore a car that doesn't actually exist. The Ford Immersive Vehicle Environment, or 5Lab, is one of only 2 of its kind in the world. It's basically a big empty room with a seat and a steering wheel sitting in the middle of it. You can put on this virtual reality headset and a glove, which are tracked by 19 motion tracking cameras around the room in real time. And you're suddenly in a virtual showroom, experiencing a car in 3D. You can walk around the car, get inside, inspect the interior, even press the odd button. Floating icons in the air let you change the color options of whatever car's being displayed. And there's even the option for a transparent skin. You can hoist the car up in the air to walk underneath it or plunge your head straight into the engine bay. The 3D models are incredibly detailed, right down to the engine parts, so you can feel what it's like to be a piston or surf down the drive shaft if you like. Ford's design team uses the 5Lab as a very early step in prototyping before any physical or clay models are made. It gives them a chance to put each vehicle in a number of different environments and test out different ideas in terms of engineering or fit and finish. Uncanny. The vehicles, in this case a Mustang, render in Ultra HD and respond to lighting and reflections as well as any video game. Ford doesn't seem to have any plans to make this a sales tool, but a 5Lab would be absolutely stunning in a showroom. Mind you, you might struggle to get...
So look at the way in which people are looking at using this kind of environment. You can also say any new product before actually making, or after making it, if you want to explain the product, all that can be done from such environments. I'll skip this video. I'll be giving you this input so that you can see it in the lecture. Now, let us look at other applications. How many of you have lost the way inside a mall? And if you had a device saying that, okay, this is where I am, and I can navigate through, or you want a grocery item, you need to ask 10 people to find out where is that. So if they had an AR application available, as soon as you get in, you should be able to navigate through this. It can be for inventory management, the items available, how many are there, where it is available, things of that can be very easily done. And training and repair services, and if you want to train, and this is the place where we are interested in, you can make use of VR as well as AR. This is the example which I have mentioned earlier. I have something like this in a physical dimension. I have it in the CAD drawing. I want that to be put in the actual place and see whether I'm able to do a work around with that new model which I have. Or it could be for a CNC machine and robotics together. Or if you want to train someone on the equipment, and this equipment also could be manufactured by different country people from different country and getting assembled at one location. All that is possible with this. You look at this example. Now, here if I want something to be replaced, and I have the model of the same, this is actual setup. What I see on the camera is actual setup. One item I can just unplug and try to plug a new one and see whether it will really go there or not. Before I really order the item, I can find out whether it will fit in and then decide to buy. For extensive testing and assembly, I'm sure those who are from computer science and electronics background, if you get into any of the data center, or if you can just get into a room where you have all the network cables and network switches are available, you will go mad because the number of cables coming in and going out, and where it goes, where it comes, even the person who did may not be knowing. Suppose you had an activity which is done on an augmented reality. As you point on that, of course, it has to be mapped, and you should also have tags available so that you can identify and say that, okay, these are the things which comes from the fiber, or these are the core switches, and these are level 1, layer 2 switches, or layer 3 switches, all that kind of input without really going back to your manual. From the model, you should be able to trace it if you have the manual ready. Otherwise, with an AR kit, I'm sure that it will become much more easier for us to get things. And if you're looking at civil engineering applications, before the actual machine, the items comes in the construction, you should be able to do many of these things with just the tab available with you. It can help a lot in logistics and also in design. And in the training, AR and VR is going to really help us in training activities. This is what we were looking at in the initial stage, wherein we wanted to, in 2010, when we made that virtual tour of NITK, our interest was to create a virtual tour of a complex device like an turbine and turbine operations and things of that kind. So the next generation instruction set could be a VR, or if you have a device like this, it could be an AR device. So as soon as you point item to the camera to the item, it will tell you what it is and where you need to do what. And those who have purchased some of the furniture from Amazon or any other online website, and if you are not a good engineer with good skills on drawing, you will find it very difficult to assemble. I have seen my own friends who purchased items, so good looking items, especially furniture, and failed to assemble it, even though they were engineering graduates or engineering postgraduates. So these kind of approaches can help us in doing that. This is another example for an engine management system. So these are the applications. Now, all these are someone else's activity as such. Now, let us see whether we can get into more on AR, VR education and for e-learning approaches. So I'm sure many of you are exposed to virtual lab. So today I like to show you how would it be make it more immersive. So I'll just take you to the website, that will be easier. Let us just get into hydraulics lab and see whether we are able to get into the lab and look around and maybe go to one of the, say, centrifugal pump. I wanted to know how the centrifugal pump is working and its details. And I would like to do a simulation. So when I clicked on to that, I am taken to a virtual lab wherein the corresponding simulation is available. So you look at this and go to the next, and you can keep on doing activities as instructed. And it does step by step, and you also have theory, pre-test, and procedure, which says what you need to do in each of the stages. So that way you should be able to do, you can see here, this is what it is, and it gives you some input, etc. So where did we come from? We had the actual lab and the virtual tour of actual lab. From there we came here and looked at the simulation. Then we also provided a Lekupada. Let me see whether I'll show you Lekupada, how it looked like. I'm just taking you to the website. I think that is not linked properly. Otherwise, it should have come. This is a Center for System Design's YouTube channel where we had put all this. Let me just show you the playlist. It's all interconnected and interlinked, or rather hyperlinked to the virtual tour which we created. So assume that I'm going to a strength of materials lab. Let me just look at the full playlist. So if I want a strength of materials lab, one of the experiments maybe tension test. It will explain.
Reimagining agriculture with data.
Give me another 26 seconds to skip the ad. Okay.
Torsion test on mild steel.
Okay, this was torsion test, not tension
This
test.
is the experimental setup.
This is the actual
The
experimental
object of
setup.
this experiment is to study mechanical properties of mild steel under torsion. Measure the diameter of the torsion test sample at 2 or 3 places and the average value is obtained. Gauge length of the specimen. This is to study how
The procedure is given
level to the motor
well in
and
advance
slowly apply the
to the student. Now, the student can also look at the procedure to do this and simulation. Corresponding simulation, you can go to the virtual lab, find out whether there is in civil engineering, there is a corresponding lab available, then do the experiment. Then see, now two things have happened. One is actual experimental setup is taught or rather learned using an VR approach, and the student know what to on, what to switch on, what steps to be done. Then an simulation experiment is conducted. So after simulation experiment, all the data are available. The student has even undergone the calculations. So with all this pre-planning, doing everything in advance, comes to the lab. Now, you don't need to explain the experimental setup because the student have already gone through that. Then you get more time for interaction. So student can even keep asking you questions. What will happen if I do this? If I give a higher load, what happens to the engine? Or if I increase the speed from this to this, what happens? All the discussions can happen when we are able to convert our most of the things which we do it in the laboratory, the learning activity that is can be put to a flip mode wherein they come from the hostel when they come or from the home they come, they are already clear about what setup they are going to work on, what are the knobs and buttons which they have to use, what sequence the experiment need to be done. All that is clear. Then if that is the case, the teacher or the tutor there will be able to get more time to discuss and find out what else can be provided to the student. From here, let me go back to, so we had a series of such experiments. I would strongly suggest all of you to go through on the virtual lab. And in case if some of your institute is not become a nodal center of a virtual lab, you can also get in touch with us. I know M.G.R is a nodal center. What we did is we did one step ahead in terms of virtual reality. We took it to the transdisciplinary work, and whatever equipments available, we started using for it. I'll show you some of the work in bit later. And we also had virtual labs. This part I'm leaving for my team members to demonstrate it tomorrow. We are working with an organization. Hopefully they will get a chance to demonstrate some of the things which we did with them. From there, we started looking at how do I excite my students. They have gone through some of the things, but now they are ready, they have time. They are ready to get into more experiential learning and also get into transdisciplinary or a multidisciplinary work. So we started working on quite a few things. Probably few we will show you how we went about. We wanted students to think about carbon credits and how do we make sustainability, and asked a group of students to come together and start conceiving an idea and convert that conceived idea into reality. So this was one. We saw that many of them were using two-wheelers in the room, in the hostel. In fact, it is not much of a distance, I think around 400 acres of land. We said, okay, if they are not willing to use a cycle, can we give them something else? So that was a concept called e-scooter, where they can just stand up and go like this. And this we converted and got a product done. And in this process, we are able to make the students to work together from electrical, electronics, mechanical, and computer background together, because it needed to be integrated with our management information system. We have a student-made ERP solution, which is called Iris, and they need to make sure it is integrated with that. And they have made an app which will work both on iOS as well as Android, and make sure that a user with an Iris login can use this. He can have a prepaid application, amount can be paid in advance, it will get deducted, all such things. Now, if we are able to make these things together and show them in a virtual reality environment, tomorrow probably they will show you some of the examples, not necessarily this, wherein how we can pick up items and assemble it and do things. So this could excite many students. They came forward and started working more. And even during this COVID period, we saw that students are able to sit at different places, make design, and few team members were here. They started working together on that, and they created an e-vehicle. And another, because we looked at our requirements, this was the one which we had created for dispatch of papers and other things. This is another student-friendly vehicle which we created, making sure that students get involved together, work together, they experience. So these are the 3 products and 1 e-scooter. 4 product we made, and all this made during this COVID time itself. And we also we lost one of the professor. We named this device with his name, where we used to go for many bathymetric survey and sea water as well as the river water surveys, etc. So we had made an unmanned surface vehicle which can do many of these things together. Also took up some activity from Jammu and Kashmir, IIT Jammu, the entire project management, construction management we took up using drones and other LIDAR survey, drone survey, etc. And also did a lot of 3D printing. Now, let me see whether I can show you some AR applications done here. You will have a YouTube video wherein, because showing AR otherwise is a quite time consuming work. So we had created videos, and let me see whether I'll be able to, yeah. It's in Kannada, but it is for the local government we made. So you will also see we make use of our own students to do all this, so they get exposed to the area of, or they get a chance to work on the area of their passion. Let me see whether I can show you. Yeah.
ಸಣ್ಣ ನೀರಾವರಿ ಇಲಾಖೆಯಡಿ ಪಶ್ಚಿಮಾಭಿಮುಖವಾಗಿ ಹರಿಯುವ ನದಿಗಳಿಗೆ ಪಶ್ಚಿಮ ವಾಹಿನಿ ಯೋಜನೆಯಡಿ ನದಿ ಪಾತ್ರ
Look at the technical part of it.
ಅಣೆಕಟ್ಟುಗಳನ್ನು ನಿರ್ಮಿಸಿ ನೀರನ್ನು ಸಂಗ್ರಹ ಮಾಡಿ ಜನರ ಜೀವನವನ್ನು ಉತ್ತಮಗೊಳಿಸಲು ಉದ್ದೇಶಿಸಿ ಅನುಷ್ಠಾನಗೊಳಿಸುತ್ತಿದೆ.
ಕಿಂಡಿ ಅಣೆಕಟ್ಟು 38.1 ಮೀಟರ್ ಉದ್ದ ಇದ್ದು ಇದರಲ್ಲಿ
I'll just show you the technical part.
2 ಗ್ರಾಮವನ್ನ ಸಂಪರ್ಕವನ್ನು ಕಲ್ಪಿಸ್ತಾ ಇದೆ. ಇದನ್ನ ನಾವು ನಂದಿನಿ ನದಿಗೆ ನಾವು ಕಟ್ಟಿದ್ದೀವಿ.
ಈ ಯೋಜನೆಯಿಂದ ಬೇಸಿಗೆ ಕಾಲದಲ್ಲೂ ಸಾಕಷ್ಟು ಪ್ರಮಾಣದಲ್ಲಿ ನೀರು ಮತ್ತು ಭೂಮಿಯ ಕೆರೆ, ಬಾವಿ, ಹಳ್ಳ ಕೊಳ್ಳಗಳಲ್ಲಿ ನೀರು ದೊರಕುವುದರಿಂದ ಕೃಷಿ ಚಟುವಟಿಕೆಗಳು ಹೆಚ್ಚಾಗಿ ಎರಡೂ ತಡೆಗಳನ್ನು ಜೋಡಣೆ.
It's a comparison, and also again we are getting in during this process. Can we use an AR headset, a VR headset, and see whether it can be put together?
ಸಾಕಷ್ಟು ನೀರಿನ ಅಭಾವವನ್ನು ಎದುರಿಸುವ ಮಂಗಳೂರು ತಾಲೂಕಿನ ನಿಟ್ಟೋಡಿ ಬ್ರಹ್ಮಸ್ಥಾನ ಕಟ್ಟೆ ಕಿಂಡಿ ಅಣೆಕಟ್ಟಿನಿಂದಾದ ಲಾಭ, ಉಪಯೋಗ ಮತ್ತು ಅನುಭವಗಳನ್ನು ಸುತ್ತಮುತ್ತಲಿನ ಪ್ರದೇಶ
ವ್ಯವಸಾಯ ಮಾಡುವಂತ
This we overlaid on an Google engine. So you can see how such things students are able to do, essentially because they are getting that experience of putting it together.
ಬಹಳ ಅವಶ್ಯಕತೆವಾದಂತ ಈ ಒಂದು ಡ್ಯಾಮ್ ಈಗಾಗಲೇ ನಿರ್ಮಾಣವಾಗಿದೆ. ಬಹಳಷ್ಟು ಅಚ್ಚುಕಟ್ಟಾಗಿ ಡ್ಯಾಮ್ ನಿರ್ಮಾಣ ಮಾಡಿ ಬಹಳಷ್ಟು ಒಳ್ಳೆ ರೀತಿಯಾದ ನೀರಿನ
I'm just searching for the VR component.
ಬೋರ್ವೆಲ್ ಕೆರೆದ ಬಾವಿಗಳ ರೀಚಾರ್ಜ್.
ರಾಷ್ಟ್ರೀಯ ತಾಂತ್ರಿಕ ವಿದ್ಯಾಲಯ NITK Surathkal.
These are the devices which we use.
Ocean Engineering ವಿಭಾಗ ತಮ್ಮಲ್ಲಿರುವ ಅತ್ಯಾಧುನಿಕ ತಂತ್ರಜ್ಞಾನಗಳಾದ ರೆಸಿಸ್ಟಿವಿಟಿ ಸರ್ವೆ, ಲಿಡಾರ್ ಸರ್ವೆ, ಡ್ರೋನ್ ಅಂಡ್ ಫೋಟೋಗ್ರಾಮೆಟ್ರಿ ಸರ್ವೆ, ಬಾಥಿಮೆಟ್ರಿ ಸರ್ವೆ, ವಾಟರ್ ಅನಾಲಿಸಿಸ್ ಮತ್ತು ಗೂಗಲ್ ಅರ್ತ್ ಇಂಜಿನ್ ಟೂಲ್ಸ್ ಮುಂತಾದವುಗಳನ್ನು ಬಳಸಿ ನಿಟ್ಟೋಡಿ ಬ್ರಹ್ಮಸ್ಥಾನಕಟ್ಟೆ ಕಿಂಡಿ ಅಣೆಕಟ್ಟಿನ ಸಾಧಕ ಬಾಧಕಗಳ ಸಮೀಕ್ಷೆ ನಡೆಸಿ ಈ ಪ್ರದೇಶದಲ್ಲಿ ಆದ ಸಾಮಾಜಿಕ ಆರ್ಥಿಕ ಬದಲಾವಣೆಯನ್ನು ಗುರುತಿಸಿರುತ್ತಾರೆ.
I think I could not locate the place where that AR and VR we had introduced. Probably when you look at it a little more closely, hopefully you should get. This was to do with the application, and a few other applications we created was using the LiDAR. And remember, whenever you need to create an augmented reality application, you need first model to be made. If model has to be made using an existing device, if it is a CAD model, it is fine. Otherwise, if it was something to do with an existing model or a building, etc., we use LiDAR survey for a scanning, which is using light. We should be able to get the entire three-dimensional object recreated as if you are doing from a CAD model. It's called a cloud point approach. Millions of cloud point will be mapped, and that can be converted to either a surface or a solid, and you can get three-dimensional objects. I'll just get out of this and yeah. So here, in order to create awareness among the students, how they can make use of AR and VR for educational applications, we started making items by cardboard and things of that kind to make that headset. Because if you ask someone to buy a 50,000 worth headset and make you put your camera on that, the mobile on that, and ask you to view, it may not go well with an Indian community, Indian students as of now, because we have a large mass to be taken care. So what our approach was, we could laser cut many of these paper items using normal laser cutting device, laser machines which we have, and we could post it to the students. They could just fold it and get an headset available at very, very cheap rate, and then put their mobile and see this lab, all the virtual labs which we had demonstrated. So I'll also show you those who are not familiar with virtual lab. So you can go to vlab.co.in. So this is a virtual lab website, and there with the domain, depending on the domain, you will have the activities which is possible. And I'll just show you one experiment, one item which you can do. I'm coming to a real-time lab, that is a remote triggered lab from NITK. It's called reconfigurable, not cantilever beam. I want reconfigurable pendulum. So go here, get into remote triggered lab. I'm starting from an external network. I'm at my home, not in the college now. So here your video should come. Today my network looks to be quite slow. Yeah, video has come. So this is an actual experiment. Now I just trigger this experiment. Now you think about how do we implement an VR or an AR application to that. This is an experiment which I want to do it remotely. Okay, remotely triggerable experiment. It's an actual experiment sitting at NITK, and wherever you are, you should be able to trigger this experiment. So this comes with a lot of activity to do with computer science, communication, and then the core engineering where the experiment belonged to. So it's a simple pendulum experiment, but all the data sensed need to be fused and sent it across. And you should also have all the conditions when an experiment of this kind is kept online, how to protect that experiment. If somebody gives you a value which is not useful for that, and if someone has forgotten to do some activity, how it can be, all that. It is called exception handling. Those who have taken compiler design, I'm sure that they will appreciate the exception handling in a normal compiler design in computer science is what we implemented in a mechanical engineering device or a civil engineering device per se. You can look at it, and implementation of number of sensors, how we can protect the hardware from external misuse, etc., are put together on this. Now on here, if I can just look at this with an VR headset, I can also get much more details from here. So I got this, and I'm now trying to change the length. It is already at the highest length. I'll change it to lower length and say change length. You can see I'm keeping the cursor at that green position. If you're able to see that, you can see that ball is moving up. So one parameter variation has been achieved. So take it as one parameter variation. Of course, you can map it to any other experiment which you would like to do it in your domain. So let me just scroll it down and trigger again. Once you trigger this experiment again, you will get one more set of data. So likewise, we allow 3 times experimentation. So you can put maximum distance, mid distance, and the least distance, and you can find out what kind of data you get. Maybe I'll put it at the middle and then see one more data. And this data can be downloaded. You can download this data, and you can also find out what is happening as the length changes, etc. Let's come down. Once it stops, I should be able to trigger the experiment once again. I get 3 sets of data now, and all the 3 sets of data I can download. I can make sure that students are able to proceed to the calculation after downloading this, and they are asked a set of questions to understand what all things they have understood from this experiment. You can see all the 3 data here. Similarly, we had created it for other experiments also. And presently, we are working with another organization to make sure that we are getting into all these 2 AR applications. Fortunately, AICTE has identified all the private organizations who are contributing to education sector and put them in one website. It is called NEAT, National Education Alliance for Technology. The advantage here is when you get into this website and make an purchase for either for your institute or for individual. Then when 4 or 5 members do that, the 5th member or the 6th member, it will be given to people who are economically poor. So that's what the ministry is looking at. So personalized learning, what all can be done in order to create that personalized learning, where we are working with a company called Feast Software. They make engineering online. It's an augmented reality mobile app. Tomorrow, hopefully, they should be able to give you a demonstration. And they also have engineering online, where different kinds of subjects are available, both AR as well as VR mode and simple simulation mode. So it's an IIT Bombay startup company. We are working with them to enhance experiential learning for a wide variety of topics, starting from ITI level skill development to diploma and engineering, and even to sophisticated instruments. If you want an explanation to be done, we are looking at possibility of using AR and VR to get such things. So many times equipment is available, nobody is there to tell how to use it. So can we avoid that? Can you just because nobody knows how to use it, the equipment should not lie there. So such things are possible using the present approach of AR and VR. With that, let me just conclude the talk, because I know you have been sitting so tight with. Let me pause share. Yeah, stop sharing. Yeah, you have been having continuous classes for a long time, and so I thought I will only cover 1 hour in the afternoon, and tomorrow morning, hopefully, anyone from MGR, can I get a confirmation tomorrow whether Fish Software is giving a demonstration to the FTP or only to your organization? Vijay Kumar or anyone from MGR? Is there someone on the other side? Or all of you are muted and cannot unmute? I don't know.
Sir, morning we have a demonstration, sir, in this AR and VR, sir.
From Fish to Software, no?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So, my idea was I wanted them half an hour to be used now. So I had told them that we can either do it in today's just after my class, and hopefully tomorrow they will get a time slot of at least 1 hour and demonstrate some of the things which we were doing together. So it's more about using it and applying to what you're doing, like the teaching and learning, rather than, I'm sure that all the 5 days there will be sufficient theory which is covered. But if you can pick up one module and say that I want 3-4 students to come together, start making something, and that will be the success of that FDP. So that's why we want people to do engineering rather than read engineering. So when it comes to AR and VR, we started quite early, of course. Earlier it was not getting picked up quite well. When I said 2010, we made that the entire circus to make a 360-degree view, because that time we did not have, rather it was not available in the market, that kind of a camera which single camera can give you 360 view. Now, of course, Theta and many other companies have provided a single camera, single device, which will get all the 360 degree. And earlier we used 6 GoPro cameras and did a lot of coding in order to get that 360 view. But of course, we learned a lot of things. Our students could really enjoy doing it. And from there, now we are looking at how do I look at a huge engine. If I want to open it up and show the students in an VR environment, how do I do it? Or if I want some concept to be clarified using virtual lab, how do I use virtual environment or VR for such things are our present focus. So I was trying to tell you, how do we look at AR and VR from education perspective? As a teacher, how do I want AR and VR to come into play, so that my laboratory time, I can use it for more to interact with actual activity, rather than trying to show how an induction motor need to be connected and how to load it and take the reading. The actual reading taking, if you remember, let it be an IC engine experiment or a load testing on an induction motor, or even for an SCM or any such experiment, metallurgy experiment or mechanical or electrical experiment, the time taken for that experiment is very less. Whereas we spend a lot of our time in making a small group of students come near the equipment and telling them what the equipment is. If all that can be flipped, so we provide all that on the website itself now. If you see fluid mechanics lab or strength of materials lab or many other labs which we have created in virtual lab, all that videos, activities are available. Now we are updating that to an VR manual or an AR manual, I should say. You take your mobile, go and scan the equipment. It will pick up the required information and tell you what to do. And it will also guide you where exactly the switch is. So it will say this direction, you turn your camera, there you have the switch on that, then look at this, etc. is the one which we are now presently working on. And demonstration on an AR, VR like this is not very comfortable. I'm not very comfortable. That's why the team tomorrow hopefully will be able to show you a good demo, because the demo site, it's a demo activity. When you want to do, you need a high-end workstation kind of a laptop, which costs you nothing less than 2 lakhs to 2.5 lakh. And it need to have really a fast rendering approach, so that when the headset is worn, you will get whatever you are seeing on the headset, you can also see on the screen, and that can be displayed in Zoom or other activity, other online platform. That's what we are trying to do it tomorrow morning. Hope with that you will get a much more visible idea on how AR and VR can be used for education purpose. So with that, thank you for patient listening. Today we did not have any interaction directly. Otherwise, normally every fourth slide I used to have something to act for the people. But today afternoon I thought I will not disturb you on those things. With that, I am winding up. If you have some questions and if I have the answer, we can discuss on that. Thank you.
Thank you, sir. I would rather ask the participants to ask few questions. If you can, if you're not able to ask, you can put that in the chat box. Questions.
Sir, I have a few questions, sir.
Yeah, definitely.
Whether the inputs in the AR application are only by coding or by image inputs or scanning, like scanning or by both, sir?
What we are doing presently is we have a photogrammetric input which is coming in. So, and then we convert that into 3D models. See, there are two issues here. If it is an unknown location, we can just manage with whatever camera is showing. But if it is a known activity, for like in case of a UTM, universal testing machine, we know the equipment as such. So we scan it and get it as a 3-dimensional model, because there is no need to create a 3D model using CAD package. We can very well scan it. Either you can use a photogrammetry, which is taking photos and getting into a 3D model, or if you want to be a little more sophisticated, you can use photogrammetry along with the LiDAR and get the 3D model. On that, we identify each item, we are able to disassemble, put it together, and this will be the actual device you are working with. Now you take an AR kit, assume that in your mobile this app is available, you take and show to the item, it will be able to recognize the image and get quickly to the application and start doing things. And now we saw that that is not that easy to do. We started using QR codes, so that the entire device, if you are not able to capture and image identification become difficult, you have a QR code there, the device identifies this machine, hence it need to search only for few things. So it become much easier. It is actually a guiding to say that where I should look for the data. And that's how we are managing. So we are making 3-dimensional model wherever we need, either by CAD, that is Blender and other software you can use, or any CAD package for that matter can be used. And otherwise, we are looking into existing devices scanning both on photogrammetry mode as well as on LiDAR mode. We scan and get precise three-dimensional models. And you can extract the feature from the three-dimensional model. Instead of complicating such issues, I would like people who are just entering, start doing something, then look at the deeper sense rather than getting into activity which everything will look Greek and Latin if I just keep talking about the details about what we do in that. Instead, my request is if you are new to AR and VR, try to understand how to implement for a small case, then grow slowly onto that. Yes, Rahul, whether I have answered your question or you have further
Yes, sir.
clarifications.
No, sir. Answered, sir. And there are other questions too, sir. Like as you said during the lecture, like the scanning will be taking place of some kind of light. May I know like what kind of light will exactly be used during the scanning, sir?
No, you mean the LiDAR or when I am doing a photogrammetry?
Yeah, both, sir.
So LiDAR, you don't need anything. It should be a non-reflective light can be used because we use it using, if it is a large area to be covered, we use it using a drone. Assume that NITK entire area need to be mapped. Then we use a drone, fly around in a mission path, mission way, and get the entire data. That will be millions of point clouds. So this point cloud can convert that into, there are softwares available which this point cloud can be converted to surface or three-dimensional objects. Okay, that is one. And if it is a small item like an equipment, we have a turntable with lighting arrangement. You go to any product photography studios, you will have a table on which the item can be kept. The table will rotate and you will have the camera at a fixed position. That is one approach. And we also use scanning cameras or the scanner which can go around the person. Suppose if you want to take the entire three-dimensional view of your face and you want to give a visitor came to your college, you want to give him a 3D printed object of his own face, assume. So when he is talking to us, we can just make somebody to scan his entire face, get a three-dimensional model of his head, and within another half an hour or 1 hour, we should be able to 3D print his small shape, not the bigger one, as a memento and give it back to him. So that also we do. It is the normal lighting which we need. And if it is LiDAR, we do it in a daytime, of course, and there is no lighting. It is not dependent on light.
Okay, sir. Thank you, sir.
Sir, there are two questions in the chat. Are there any physical effects, long-term physical effects of using virtual and augmented reality? And then the next question is how we can go about starting our research career in AR and VR field.
Yeah,
thank you, sir.
And the first part is really a good question because I'm sure that when mobile came, everybody was worried whether how it is going to affect. When it is a headset which is completely covering you, orientation is going to be an issue because we have been experimenting with our students in the lab. In this virtual environment, the way in which you behave is quite different. And we have been making fun of each one of them when they wear the set and start, because they have to go and pick some item and put it together. They have to assemble, because all this electrical vehicle activity, we created virtual reality kits. So all the parts are kept and they need to pick items in the VR mode and assemble it so that everyone understand how this assembly and system integration happens. It will be real fun to view when they are doing, because we don't see what they are seeing because you are not projecting. It is only in the VR on the headset. And I'm sure that it is going to have a lot of issues along with it. If you find issue with your mobile, you also find issue with your AR and VR activity. And people may not be able to really put 100% use of it if they don't know what are the pitfalls. I mean, I would like to stop at that, because otherwise if we give the negative points more, development in AR and VR will get affected. We'll presently say, even if it is Amrit, nectar, don't use it more, it could become poison. So use it as required, because you are putting something on your head, your entire visual things are just the eye is focusing only for a short distance, it can really affect you. But for a shorter period, for some training activity, if you want to use it, it is fine. I mean, that's my answer for that. How to start AR VR research? When you say research, you need to see what is that you want to really do. Are we looking at algorithms that can make computation faster? That is one area. And all the gamers are trying to see, can I make all the physics applicable in such a way that all this physics is done with minimum calculation? When I am putting an air upward, all the cloth around should move up. And then only you feel that there is air moving up. Okay. Or when you are putting an item down and you want that item coming down, but the less weight items like a feather or a cloth should move up. And these things are called physics. I mean, how to implement physics in this kind of application is an area where a lot of work is going on. With minimum floating point operations, how do I implement actual physics in an AR and VR environment? That's one area. Visualization is another area. And we saw how do I do computing much better way with available resources? How do I do computing? And can I predict what is going to be the next request from the AR guy so that I can keep things happening in the background? All these are the possible research opportunities. Obviously, for mechanical engineers, modeling and getting data from the cloud point is another area where how do we get such things? Not necessarily mechanical, it can be even for computer science. Algorithms are the one area where I look at very actively. And we are also looking at AR and VR for marketing, AR and VR for products and sales, and its influences. We have put one PhD student from management to look at such things now. So there is a lot of opportunity on AR and VR. Your sky is the limit, and the way in which you look at it decides what research you can look at. Because we are from a transdisciplinary domain. I work with engineers and non-engineers, hence my approach may not be very suitable for many of you, because now we are doing something with fisheries college. We are looking at fish seeds and things of that kind. We want to train local artisans on fish culture and things of that kind. Then we are looking at and we are slightly differently. It should be in the local dialect, local accent, and items should be familiar to them. And it's altogether a different ball game there. And same way, we are also trying to do something with farmers. There it is altogether different. And when you are working with engineering students, it is much more comfortable because we know what we know what they are looking for, and we are able to do it much easily. I mean, that's my answer for how to start AR VR research, which could be impending growth of AR VR. The cost of the item. Why AR VR is not really getting popularity is who will spend 50,000 rupees for an headset? That's why the Pokemon was very popular. It was the first augmented reality game where your area is getting mapped. On that, you need to do things. Such things will be the much better position rather than VR. VR, we also tried with the Google Glass, cardboard, and things of that kind. But still, if you are wearing that for half an hour and trying to do things, we did not find our students that comfortable for a longer period. Those are the impediments actually. And how, one more, sir. Yeah, how to secure. Probably you will have somebody else talking about security and data theft. I mean, I hope someone will talk about the augmented reality issues. That is, you're always keeping your camera on. Okay. You are okay with what you see on the street, but the company is more interested what they are seeing from the camera. They can find out who is there, who is going to which shop. All that information can be mapped. So one of my friend who had this smart device happened to have a 4-day continuous argument with his wife, and Amazon Alexa was listening to all that. And you know, both husband and wife, when they logged in next time to Facebook and Google, they got the nearby diverse lawyers' address and advertisement. So data and privacy is going to be one of the major issue. Second, I feel it is more to do with the headset and wearable items which we have creating more difficulty. That is my answer for securing AR app. And I'm not an expert in cyber security, hence I have limitation in answering how are they overcoming, etc. I know it is important, only that much I could give you answer as such. How do you manage to get these headsets? Are you talking about the headset which we made on cardboard, or you're talking about the commercial headset? Commercial headset, as long as you have money, go to any one of the online site, you'll get plenty. And nowadays, even second-hand refurbished items are also available. And if you're looking for Google Glass or Google Cardboard, just type on the same. You need to get the 2 lenses, which is again available online, and the pattern is available. You can even hand cut it, or if you have access to a laser cutting machine, you can put stack papers, cardboards together, get it cut in one slot. That's how we made for many such things, so that they can use their own mobile phone. Now AR and VR applications are available, at least some videos are available quite well. So you can ask them to start using it, but not for a very long period. If you have a kid or someone who is using it for a long period, it's going to be really impactful on their eyes and even the mind as such, because they start believing on it.
Yeah,
Is there any other questions? I mean, any collaboration? How to manage to get this headset? I mean, any collaboration? You mean whether we have any collaboration with some companies? Presently, we don't have any collaboration. If I have understood that question correctly, we don't have any presently collaboration. We are, of course, actively interacting with groups, but they feel their product is already well developed. That way, I don't think they need anything to do as such to start with.
Thank you very much, sir, for patiently answering queries on this fast growing, it's an exponentially growing field, I think now. And so I think with this, sir, I think we can wind up today's session, sir. Thank you very much, sir, for taking time out from your extremely busy schedule and contributing your knowledge for this particular field, sir. Thank you very much, sir.